Alright, here we are, Math 2, Unit 9, Lesson 7.5, still areas, regular polygons, looking at Form K, just an additional worksheet. Again, I'm not sure if your teacher started with Form G or Form K, but here's a little bit of what you have. Both forms are very similar, so I'm going to go through a couple of these. I did more on Form G, so if you need more help, I recommend you watch the video on Form G. So I'm looking at 3, 5, 12, 19, and 21 as I'm looking at today. So here we go. Beginning with number 3. In order to solve these angles here and figure out what's missing, I'm going to have to find out what the central angle is going to be. I recognize that, I have to look at the number of sides to find the central angle. And then I'm going to see here, number 2, this is going to be a central angle divided in half to make this the apothem here. And then to find out the missing measurement, I'll do 180 degrees minus 90 minus the number 2 to find number 3. So let's take a look at number 3 first of all. I have a shape with 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So to find my central angle, I will take 360. I will divide that by 9 and come up with 40 degrees is my measurement for angle number 1. Now, measurement of angle 2, we said, is going to be that central angle divided by 2. So what I'm left with for number 2 is actually 20 degrees. The measurement for number 3 is going to be, I have a 20 and I have a 90, so I'm already at 110 degrees, and it's whatever's left out of 180. So I take 180, I subtract 110, and the measurement of angle 3 is 70 degrees. So I have 40 degrees for number 1, 20 degrees for 2, and 70 degrees for angle 3. Let's move over here to number 5, and again, I did a lot more of these on Form G. So if you need more help, I recommend you go back and look at those. Form G. In order to find the area of a shape, what I have to do is recognize my formula is the area is equal to the apothem times the perimeter divided by 2. Okay, that's my formula. You might have seen it this way. It could be 1/2 times the apothem times the perimeter. That's the same thing, just a different way of writing it out. So whatever way works for you or makes most sense to you, just stick with that, and that's okay. All right. So here we go, hexagon. We know that a hexagon is a shape that has 6 sides. We have an apothem already given to us. We have the length of a side is 3, so I don't have a perimeter. So let's work on the perimeter first of all, because I can see I have my apothem. I just need the perimeter. The perimeter is going to be equal to the length of the sides, 3, times the number of sides, 6, which is 18. So once I have that in place, I can now use my formula and say that the area is going to be equal to the apothem, 2.6, times the perimeter, 18, divided by 2. And when I put that into place, I find that the area is equal to 23.4, and this is feet squared. So that's my area there. Same thing for these ones here. Again, you have your decagon, your nonagon, so make sure how many sides those are before you keep going on them. Okay? All right. Looking down at number 12. Number 12 is a great question. What we have here is we have to find the area of a regular polygon. It does want me to go to the nearest 10th, which means I'm going to be multiplying out those radicals to figure out what they could be. So let's take a look here. Number 12. I begin with noticing that it is, again, a hexagon. We have lots of hexagons in these worksheets. So the central angle here is my first step to find out what's my central angle going to be. Well, I take 360, divide it by a number of sides, and we find out that I have a 60-degree angle right here. Not done yet because I need my apothem and my perimeter to solve the area. So I'll make my apothem right there, which means I take my 60 and I divide it in half. I'm going to redraw this triangle real quick for you, just so we're on the same page. There's my apothem. Okay. Draw this with my camera. There's my apothem. There's one of my side lengths, and here is this angle that we just formed. We said it was 60 was the whole thing, so when I cut it in half, that makes this length equal to 30. If that's 30 and that's 90, this becomes 60 degrees. Okay? Now, we said the whole thing was 3 inches, which means this half of it is half of that, which is 1.5 inches for this side length right here. And again, that's because the whole thing is 3, so if I take half of it, I cut it in half and I have 1.5. Alright, this is a special triangle, and one of these triangles is this: if my short side is x, my short leg is x, my long leg is x root 3. So because x was 1.5, in this case here, my apothem is equal to 1.5 root 3. So I know what I know about special triangles, x, and this becomes x root 3, to find out what the apothem is going to be. Again, to solve it, remember I'm going to need to have an area equal to the apothem times the perimeter divided by 2. Right now, I have my apothem. I'm good there. Next, I need the perimeter. The perimeter is the side length 3. Right? Perimeter equals the side length 3 times the number of sides, 1, 2, 3, 4, 5, 6, for 18. So now I have my apothem and my perimeter. I can plug those in, and I'm going to solve the nearest tenth. So let's go ahead and plug it in here. It's going to be 1.5 root 3 times the perimeter, 18, divided by 2. Alright, so when I work that out on my calculator, I have, there you go, I have 1.5 times, use my second thing, and let's go root 3, close that off there. So that's 1.5 root 3. Now multiply that by 18. I'm going to go ahead and press enter, and then divide that by 2 to come up with 23. Now I want to go to the nearest tenth, so 3.38 becomes 0.4. So my area is going to equal 23.4 inches squared is my final solution there for that, number 12. Alright, let's move on to the back side. So look at a couple of these real quick. Number 19, and then I really want to make sure you look at number 21 because I didn't do one like 21 on Form G. Okay, so number 19, first of all, this is a triangle once again. I'm going to need to find my central angle and do my kind of cut up to see what I got there. So what I'm talking about is finding out what this whole angle is going to be. It is a triangle, so I take 360 divided by the number of sides 3 to find out that my central angle is 120 degrees. Because I'm cutting it in half to make the apothem, when I divide it by 2, I discover that, hey, that angle is 60 degrees. So again, what I'm looking at is make this bigger here. Make that there and there. That's the triangle I'm looking at. What I know is that is 6. My apothem is 6. This is now 60, which makes this 30. So my short side is 6, which makes my long side 6 root 3. Okay. Now again, that is only one part of the triangle. The other whole side would be 6 root 3 times 2. Okay, so basically the whole side length is going to be 12. I'm going to write right here so you can see it here. So it's a 6 root 3 times 2. So I end up with 12 root 3 is my length of a side of the triangle. Okay. Again, that's not my perimeter. That's just the length of one side. I could also look at it as 3 parts and multiply by 3 or 6. However you want to look at that. Okay. At least I know I have my apothem and I have a side length. I need my perimeter now. My perimeter is going to be 12 root 3 times 3 sides. So I have 12, and then my root 3 times 3 sides. And so my perimeter is 62.35. Alright, and my apothem we said was 6. So when I plug in my formula, my area is going to be 6 times 62.35 divided by 2. So I'll take my number there, multiply it by 6, and then divide it by 2, and I come up with 187. What? That seems a little crazy. Oh, I know what it is. Sorry about that. I forgot. Read the directions. No! Radical form. Keep it in radical form. So sorry about that. So let me back up just a hair. I was doing what I did on the front side. So my perimeter is going to go ahead and stay as 36, perimeter, sorry, is going to stay as 12 root 3 times 3. So my perimeter will be 36 root 3. So let's change this right here to 36 root 3. 36 root 3. That's a little better there. So that gets cleaned up. And now what I have is 6 times 36 equals 216 divided by 2 equals 108. Root 3 just stays where it is. And I leave it like that in the radical form. So 108 root 3. Sorry about that. I was doing what you did in the first page. So front page, you multiply it out. The back side, you leave it in radical form. Okay. Number 21. I will look at 21 because we haven't looked at this type of triangle yet, and it's asking you to kind of go the backwards way on this one. So in this case, I have a square. All right. So with a square, I had the radii there. I don't have an apothem yet. I can find out the central angle with a square by doing 360 divided by number of sides is 4. Okay. So 360 divided by 4. 360 divided by 4 is 90 degrees. Right? So I have 90 degrees there. Great. No problem. 90 degrees. Now when I cut this in half to make my apothem, now I have a different kind of triangle. Now I have a 45, 45, 90 triangle. Okay? So I have 45, 45, 90. Now we already know this side length right here, or this radius, is 26. I need to find out what my apothem is going to be for my formula. I also need to find out what this side length is going to be because I have to know what this is in order to find out my perimeter of my whole square. Now our dilemma is if you don't remember this one, hang on with me, with the 45, 45 triangle, this is a 45er, sorry it's not great, we learned that this was A and that was A and this one was A root 2. Remember that? Well, this time here we have it the opposite way, where they gave us the hypotenuse, and if they give you the hypotenuse as A, your side lengths become A root 2 divided by 2. A root 2 divided by 2. So in our case here, we're going to take our 26 and to find the value of A is going to be equal to 26 root 2 divided by 2. If I want to work that out a little further, it's 26 divided by 2 is 13, and I end up with 13 root 2 for my apothem. Now that also means this side length is also 13 root 2. Okay? Now because this length is 13 root 2, and I have another side over here at 13.2, I have a combined side length here. My side is going to be equal to 26 root 2. That's my side, which makes my perimeter, because it's a square, 4 times that. So 26 times 4 is 104 root 2. So I have an apothem, 13 root 2. I have a perimeter, 104 root 2. And so now I'm able to use my formula. Again, we're going to keep it in radical form. So my formula is 13 root 2 times 104 root 2 divided by 2. Okay? So, here we go. Let's do, first of all, 104, or 13 times 104, which gives me 1,352. Now, I'm not done yet. That's just this times that. Now, real quick, here we go. Root 2 times root 2 is equal to, let's put this here. So, a root 2 times a root 2 is equal to 2. And we have the whole thing still divided by 2. 2 over 2 becomes 1. So we're left with simply 1352. So even though it says to keep it in a radical form, my radicals actually will go away because a radical 2 times a radical 2 becomes just a regular natural 2, and 2 divided by 2 is 1, so I'm just left with a 1352, in this case here, centimeters squared for my area. So I wanted to make sure you saw that one because it's a little different because we are dealing with a 45-45 triangle and working backwards. You have to recall that from one of your previous units. All right, that's it. Hope that helps a little bit. Have a great day.